All right. You want me to do the intro again? Cool, cool.
Only the ones here will know what they meant.
Okay. Yeah, no one else gets to know what it is. All right. So what is the engineering design process and how do we use it? So or the engineering design process for us is essentially a kind of a problem solving framework that we are able to use throughout the season to help quickly iterate and test designs and come up with ideas, things like that. It's that is a graphic of it that we have, although it's not always used in like a perfect kind of circle of events, but and I'm familiar with it build wise, but you can definitely use it for programming, outreach, things like that. A lot of teams kind of already have sort of this framework without really knowing, but this is how our team has it documented. All right, so first step of the engineer design process is to identify what you're trying to solve. So for FTC, this problem is pretty easy to identify. It's just your game. You want to read your game manual. And so for our seasons, our challenge is how to score the most points. So that pretty much solves half of our problem here. Another thing you want to do is identify any constraints you're going to have. So this could mean maybe money or parts or time, that things are gonna hold you back from your goal. So again, you're gonna identify the game, which for us means reading the game manual, watching the video, figuring out all those rules, and identify your constraints. This step really does help you kind of understand your objective, avoid any missteps or wasted time because you did something you didn't realize you weren't allowed to do, or were working on something that is like completely illegal, and helps you really work towards super efficient, functional, and feasible designs, as well as goals that you're gonna set. All right, step 2, brainstorming. So what is brainstorming? A lot of people kind of think of it as planning, as I'm going to write this down, this is going to be my plan. It's really not that. Brainstorming is a group, or the definition that I have of it is brainstorming is a group problem-solving method involving the spontaneous contribution of ideas revolving around a shared objective. So there's a lot of reasons to brainstorm, and sometimes it'll be easier than others. Sometimes you'll have a super like set idea, everybody agrees on it, great. But most times, almost every single time, it's going to be a lot harder than that. And brainstorming really helps you generate a lot of ideas, promote really creative ideas and kind of out there ideas, innovative stuff. As it helps you build off of your defined challenges and constraints from the identify step, as well as break any mental blocks you might have if you don't have ideas. And there's exactly one ground rule to brainstorming, which is no judgment. All ideas are good ideas at this stage. It's really just trying to generate the most amount of ideas you possibly can in the time that you have. So how our team does it is we essentially get the team together and throw a whole bunch of ideas at a whiteboard until a few of them stick. For a lot of teams, it can be a lot more defined than that. You could have kind of a moderator pointing out people saying, I want to hear your idea, I want to hear your idea. But the way our team does it, it's super kind of just relaxed and uncontrolled and just throwing ideas out there. Some other notes for brainstorming: record your ideas. It's really nice for judges to be able to see your thought process behind things, to see that you did the work in the brainstorming and like went over all this stuff and you made it to like that final step with your robot from this ground point. Also focus on one thing at a time. You don't want to be like, oh, this intake is cool, I'm going to jump all the way over to hanging because that's what I want to do. And you don't make progress that way. You just get distracted and then nothing happens. Brainstorming is fully quantity over quality, which is usually the opposite of what robotics is. But brainstorming, again, it's just I want to make the most amount of ideas possible for the amount of time I have. And not all of your ideas have to be from scratch. Some people will call this stealing. We in the FTC community like to call it taking inspiration. But you can scroll through the FTC forums, which I found are super helpful. Look at old robots from yours or from others. Check Instagram, social media, see what other teams are up to. There's always a lot of like robot in 3 days videos that can be pretty good. And so on the pictures, you can see on the top, that's us brainstorming, throwing ideas at a whiteboard. We're all just talking. I think we spent maybe 4 hours doing that. And then on the bottom, you can see we took down a whole bunch of old robots that we have in our tech room from other teams, previous seasons, and we're kind of weighing pros and cons. I think specifically for those ones, we were looking at things like the linear slides because that was for center stage year. And that's kind of how our team does it. All right, step 3, personally my least favorite, but arguably the most important is planning out the solutions you want to use. All right, so planning means you're essentially picking and choosing those brainstorming ideas and drafting a full robot design. And yes, this is now the time to judge people's ideas. So you want to consider things like, do I have the materials for it, the tools for it, the money, the time? Does it align with my challenge and constraints that we identified in the identify step? You want to assign value to this different criteria. So if your team doesn't spend a lot of time in the tech in your workspace, then you probably want to prioritize things that aren't going to take a lot of time. If your team has a huge budget, then money's not going to be as much of a problem for you. Do you want to score points, or do you want it to be done fast? Do you want it to be reliable, or do you want it to be like super crazy and out there? Like, you want to be able to assign value to these criteria and be able to base off your decisions off of the criteria that you decide. At this point, you should start focusing on like details and feasibility instead of just like throwing ideas onto a whiteboard and just like, at this point, it is quality over quantity. This is the plan that you want to try to have in place for the rest of your season as you move forward. And so once you have these designs, you probably want to start splitting your robot into, you know, sub-assemblies or projects. You want to assign people to work on these. So right now I was working on odometry, and that was my project. And we had other kids working on hanging, and that was their project. And this helps you not overlap with each other, conflict with each other, and everybody knows what they're doing. No one's doing nothing. You want to set deadlines for when these things need to be done. And this is kind of depending on your team. A lot of teams don't really like deadlines. They want to kind of just see where they go. Our team, we found it really helpful to have deadlines to hold us accountable. And so we'll say, we know we have this competition and we want to have this done, or we have this outreach opportunity, and by then we need to have this. And then we take those sub-assemblies and projects and teams and we assign them deadlines for that. Like I said, these deadlines should be based around competitions and other events like outreaches or scrimmages. And at this planning stage, you'll have some of the goals you kind of set from the first step, but you want to set these in-depth goals. So like, I want to have this mechanism score this many points by meet 2. I want to have this mechanism working and being able to score 1 specimen in the high goal by meet 0. That's my goal. That's what we're going to finish. Planning is super helpful to make you, one, realistic, work efficiently, ensure everybody's on the same page and no one's like in their own world, as well as makes it a lot harder to make stupid mistakes, although still very possible to do that. All right, step 4, one of my favorites, prototype. And this is when you finally get to have your hands on the robot. So what is prototyping? This is another thing I see people not doing wrong, but maybe not fully understanding sometimes. So prototyping is creating a rough draft of your designs just to test and to gain feedback, not to be legal, not to be functional, to test and to gain feedback. Will it, won't it work? Things like that. So we prototype, again, to test. It's just testing, not final. Gain feedback. So gain the information. This will work. This won't work. I think this can score points. We should move forward with this. This isn't going to work at all. We should stop. To find flaws early on, as well as to very quickly iterate through designs without getting held up by those flaws and by things that aren't going to work. So we have a few methods of doing this. There's a lot of ways to do this, most of which are not on this page. But our team's personal favorites are, 1, just taking some real cheap, real versatile materials like cardboard and tape, or wood or paper or glue, Legos, whatever you have, and just kind of building what you think might work and testing it using that. You can also use super, super simple metal models, which you can see in the pictures. Those models are not functional at all, but they were able to help us like test range of motion, as well as like how much torque do we think we need? Is it realistic? Personally, as the CAD person, CAD is my favorite way to do this, because you're able to put those real parts into CAD and simulate it as it would be when you actually put them together, as well as just get those degrees of motion and not have to have the physical part, as well as have it be a little bit more realistic. And so prototyping really helps us test, like, is this design feasible in the slightest? Like, is the degrees of motion going to work? Can this reach where I think I need it to reach? Is it worth it to build? Like, do I have the time, the materials to do this? Will it fit on the robot? Because we do have pretty specific size constraints, just things like that. Do I want to move forward with it, or do I need to take a step back and rethink it? All right, step 5 is test and evaluate your design. So testing is kind of part of a greater loop. You have the prototyping and testing loop, and then you have the test and refine loop. So testing though is essentially how we gain feedback on our assemblies, on our parts. We test our robots for like to check our progress, like are we on par with our goals? Do we think we're gonna like make our goals that we have already set? Test solutions to problems, learn how to improve, and just make sure things aren't gonna blow up, that nothing's gonna go haywire, and everything is going to work well in competition. So testing from prototyping is one of these little loops. So testing from prototyping essentially means just see if your ideas meet the basic criteria to decide if you want to keep going with it, if you want to move forward, or if you need to go back and take another idea from your brainstorming session, from your drawing board. And then you go into, after you have an idea, you keep going with it, you decide to keep going with it, you start entering this test and refine cycle. So you choose this design, and then you make a change and you test it. You make a change and you test it. And you make a change and you test it. And just to see if these changes are working, if you're getting better, if you're improving and keeping up with your goals. So testing efficiently is something that's actually really hard for my team and for a lot of other teams. So testing efficiently means you're testing any and all major changes to any assemblies and any prototypes. You want to test against constant and measurable criteria, which can be really, really hard and not always possible, but you want to be trying to do that as much as possible. So things like, how many points can I score in this amount of time? Like, out of 10 times, can I pick up this specimen at least 8 of those times? Things that are measurable, that you're going to be able to like count on your fingers. And you definitely want to document progress, setbacks, and outcomes. This is another thing that ties a little bit into like engineering notebook, where judges really, really love to see the progress you've made and the steps you've taken, and that you've taken the time to, go in, test, refine, as well as if you're documenting all of your problems, if you have that problem again in the same season or a later season, or someone else has that problem, instead of having to take the time, those hours to go figure it out again, you have the answer at your feet already and can just shoot forward. All right. Step 6 is refine, which ties back into the test and refine cycle. And so refining is just taking that feedback you gain from testing and improving on your design. So refining means fixing all the parts that aren't working, as well as optimizing parts that are working, so that you can be as efficient as you possibly can be. And so you want to make a change and then test and then document those results to see if that change really did work and weigh it against that criteria. And then you want to go back and refine again, see how can I make this better, things like that. You can see on the pictures there, that's kind of a step-by-step of how one of our parts looked last season, and you can kind of see the change that we went through, where we realized, hey, we want to be able to see the pixel color. Wait a minute, we want to have color sensors on there. We need to have motors on there, and you can just go through and keep going through that. All right, step 7, personally the hardest step for me because I forget to do it all the time, but is to share your solution and results. It's kind of plays back into that we need to document this. It helps, and like and you can do this through things like outreach. This is kind of what we're doing here. We're sharing our engineer design process. You can do it through social media. We're going to post this, or documentation, which is the big one again. Make sure that no one who has the same problem as you is going to struggle the same way you did to figure it out and spend all of that time. And you can also share this by talking with and kind of helping out other teams. So during meets, this is a great way to do this. If another team has an issue and asks you about it, it's also a really great time to go ask about your problems and see if other teams have maybe figured it out. Was super helpful when our team was figuring out things like odometry and linear slides. So I would definitely recommend that. And so the benefits of sharing are, again, others can learn from your findings and save their own time, pain, and suffering. You can receive that feedback from others and see, like, was this a good change? Should we do this again? Things like that. Helps with documentation, again, pretty important. And you get to have an effect on your team and the larger FTC communities, which I think personally is the biggest part for me. All right, and so these steps aren't always used equally throughout the season. Although the picture that we showed in the beginning made it look a lot like a loop, it's not always that. So in the beginning, from kickoff to October, that's where we are at now. It's the beginning of the season. This is when you want to be identifying your problem, brainstorming your solutions, planning out where you're going to go. You want to figure out what paths you're going to take, what your season's gonna look like, what your robot's gonna look like, you know, what your strategy is gonna be for the season, things like that. The base level stuff you need to really take off in the later months. When you get to the mid-season, you know, November, December, this is a lot more meets. You're doing, for teams that are in leagues, you're doing league meets. And so at this point, you want to try to move on from the brainstorming, from the planning, from that stuff, and you just want to be prototyping, seeing what's going to work, getting stuff on robots, making yourself competition ready, and then improving from there. This is when the cycle of prototype to test and then test to refine really comes into play and really helps you get that robot up to competition level. And then, of course, January, February are most important months, and because it's qualifying in state, and all you want to be doing, unless something is catastrophically not working, is you just want to be refining and refining and refining and refining. And this makes it so you have the most tested, the most thought out, the most planned robot you can for things like qualifier states and worlds. If you make it MTI, things like that, you don't want to be prototyping. You don't want to be you don't want to be in the prototyping testing cycle. You want, because that leaves you a lot of room to have errors. If you don't test enough, if you don't refine enough, you're going to be left with little errors that are really going to mess you up in competitions that are going to come out of nowhere and really hinder your performance. And so you want the most thought out, best built robot that you can make. All right. Does anybody have any questions? I'm gonna say that's no. I guess that means I did a good job. But I think, is that the end of ours? We have a share slide, right?
Yeah.
Contact us if you guys have any questions about any of these seminars, I guess. Other than that, I think if you want, if also just shoot questions in the chat if you want. Other than that, I think that's about it.